compressed airflow monitoring or pneumatic flow monitoring, supported to you by the SICK FTMg. So the FTMg is a flow thermometer for gases. It's designed for early detection of leaks in the compressed air system. As you all know, everyone in attendance, that the compressed air system is massive. It could be mains distribution right down to feeds to the machines, and you've got other infrastructure within your compressed air circuit. Nowadays, we're all sort of have a lot of phrases bandied about, but efficient energy management under the ISO 50001 directive is a core issue in terms of audits and compliance of your site, and also the cost benefits that you will see if you deploy the system. So in essence, just see that. Bare bones of what I'm going to take you through today is how it works and why. We'll have a cross-sectional view of the features, some of the further key design benefits, some case studies, and sort of conclusions. Just want to sort of frame this in everyone's minds. This quote from Darren Pratt, product manager for SICK UK: compressed air loss is a major source of wasted energy in production plants, easily accounting for more air loss through leakages than is used for the process itself. Judging from other SICK presentations that I've seen, we're talking compressed air itself could cost at least 4 times as much as the base electricity for your end user, for your plant. So we're looking at sort of potential for massive savings here. So just to show bare principles of how it works. So it's a calorimetric principle of operation. You see here in this bubble here, that probe is heated, it's at a known temperature, and the flow of the gas itself, that gas flowing through, usually of course it's going to be cooler than the heat probe itself. So whatever the difference in temperature, or delta T, between the heat probe and the gas flow, it equates that as an output, and that's simple flow rate. That's how it takes it. It takes it linearly. Also, furthermore, you can see that this is the insertion here on the left-hand side. If I'm just sort of hovering here, to see they've SICK have worked well to sort of fashion a low intrusion of the flow line, so you get less disruption. One thing to note is that it will have a low flow cutoff, and of course, if there's no difference in temperature between the flowing gas and the heat probe, say, then it will not detect any speed or any flow. So that's it in terms of sort of bare principles of how it works. Now, if we're looking at why this has come about, and why SICK are really making a big push for this, it all stems to the pressures that you will face on your end user sites. Now, judging from what it says in the Carbon Trust and for compliance of end users, you're going to meet quite punitive measures. Obviously, we've all heard about carbon credits and how that relates to this, and meeting consumption, sustainable consumption rather. Now, what we know is that from the outset, compressors themselves are pretty inefficient, maybe around 20% at best. And obviously plant management, you've got to account for this when you're setting up, you're sizing your compressor, you size your compressor to take into account this inefficiency. So you're sizing it for a larger duty than is required. So from the outset, you're losing, you're kind of behind, you're playing catch up in energy management. And when in your compressed air circuit, you've got items like a receiver tank that will accumulate the compressed air at the ready pressure, delivery pressure and temperature. And you've got even cooling sections there as well, like a cooling dryer. So there's all sorts of, there's so many sources of sort of loss here, and just the effects of integrity, the connections as well. That's where the gas is going to slip out from, not just from leaks in your line, where the line itself is eroded and it's opening up, just sort of hitting out here. So today, what they've done is what you guys would have done is would have had either using multi-tool specialist tools from third parties, or you've got a person to come around and audit the facility. Now, as soon as he or she has done that audit, they've signed off, they say it's compliant with the ISO and EN standards. Once they've left the site, then you've got no visibility on what's happened. So it was deemed valid yesterday, but for the next time you have that audit, you don't know. It will just be validated or invalidated 3-4 months down the line. Now, with multi-tool or having a pressure sensor, a temperature sensor, of a flow sensor, and then having to try and totalize that, you know, for just for one line, if you compress there, that's going to be a bit of a headache. String it together, collate it, make it serviceable, so you yourself, your operations manager, maintenance manager, can make interventions. It's a bit of a nightmare. So, in essence, yep. How much energy? Do you know how much energy is being used to keep that compressed air right at delivery temperature? You know, the moisture content right within spec, and are there opportunities to streamline your process? So here, hey presto, SICK have the FTMg. Now we're looking at parameters here. Flow, velocity, energy is probably your main, your key concerns. But you can have volume, flow, total volume. You can have it as a counter and totalize it to see, you know, how much volume you're using over the days, hours and days. And you know, with pressure and temperature as well, where ordinarily you'd want to put, you'd have more tools put in there, more interruptions or punctures in your line, and sort of just more headaches in terms of commissioning and checking the integrity of your circuit. Whereas you can have this at one tool or one line and spread it out, multiple units of these across the plant. So we're going to look at, next slide, we're going to look at a glance, what are the headline features. Now, here it is in the middle in all its glory. It's less in terms of way of time-intensive setup. It's flexible in terms of what we can get for pipe sizes. So DN50, DN15, 1.5 would be the inlet run to maybe your pneumatic machines or robot arms. DN50, 5.0, that would be mains distribution. That would be just downstream of the compressor. And it's not just compressed air, it's also compatible with argon, helium, carbon dioxide, and nitrogen. As you know, with buying them in from the gas company in those cylinders or through mains connection, you're facing a lot more spiking in this age of inflation. So this is perfect for your compressed gases, special compressed gases that you might use in sealing for food and preservation of certain key ingredients, same pharmaceuticals. Furthermore, it's very compact when it's in there. It's 45 mm by 110 mm, and we've got industrial and Ethernet versions available, and I'm going to that more towards the end of this presentation. But what it is, what you want out of it, which is obviously why you're all here, is visualization of the aggregate process data. So that's flow, pressure, temperature, above all, energy consumption. And this sort of cloud icon here, you get that logging, real-time logging of those 8 parameters up to the last 7 days. So what you want, what you're here for, you want a clear view of your measured variables and sort of modification or setting alerts through a PC or you know, a mobile type device like a tablet. Probably easier on the tablet. So further design benefits, yeah, like we've seen before, it's light, compact, so it makes for easy installation. Has a rotatable display as well. So if it's in an odd position, can't be helped, you can swivel that display and rotate it for your needs. Now, you're asking for, obviously on DN50, it's being a 2-inch line. There's a developed flow, sort of a laminar flow, and we want to, this meter needs that laminar flow to ensure that it's reliable, that your readout of flow and sort of pressure is meaningful. So with the DM50, you get a appendage, because like a flow conditioner tube, it's supplied with it. So it's going to mean minimal disruption for your line. So that's what SICK have kind of pulled out all the stops there to make sure that your process, your compressed air circuit rather, is not disrupted. And the way they've designed it, with that straight measurement channel, as we saw at the start through the crosshairs, the cross-section view, sorry, it minimizes pressure loss because it's a mass flow meter. It's an insertion in line. You want to minimize pressure loss, and in other devices today, that pressure drop or pressure loss in line is introduced by that actual probe element. So sick of they've thought this through and made it sort of comprehensive and disruption free as possible. So we're going to look at the industrial and Ethernet versions. So these are when we specify for you at Underwoods, these are what you would be looking at. You might think, what's the difference between the two? So you want your industrial on the left-hand side here. So I'm hovering here. We've got standard IO link with your switching analog frequencies. You can have it for channels. You can set those channels depending on current frequency, pulse, or like a relay. So stuff that you are geared towards. And the Ethernet variant itself differs a bit in the sense that it's power over Ethernet, and it's ready for web server MQTT, so your cloud. With the industrial on the left-hand side again, you can have it IO linked so that you can sort of export it to say Profinet, Profibus, or Plant Standard, and still get that through to a PLC. With the Ethernet variant, it's all there. It's all kind of set up for plug and play relay onto your web server devices. Now, industrial IO link with that's perfect. They both do the same thing in terms of the data being produced and the ability to log data. Obviously, with the industrial link, you might have more of a chance of getting it into PLC and logging it for a longer time. But with Ethernet, if you've got a manager breathing down your neck and you want sort of, hey, he or she wants to see it on their server, and they're remote, they're in America, India, Germany, what have you. They've got the login credentials. They can go in and have a look at the the data dashboards and the visualization. So we've got, with the up to 7 days logging, you can start spotting what's going on during shifts, what's going on the weekend, where are the peaks and troughs. So before you didn't have any real-time feedback on your flow and the energy consumption. So now you do. This is making planned maintenance a lot more practical, and with some higher functions of this device, better setups, you can make sort of targeted interventions. You can have alerts set up as well. So it's all down to preference here between industrial and Ethernet. So we're going to start looking at cases. We're going to have case one here. And here it's a bit grainy, but there is a view of, on the right hand side, we see the FTMg that monitoring flow from the mains into the lines feeding the machines for this is CNC milling. Now it's monitoring energy flow towards and inside the machines. So you can have one on the upstream feeding to the machines and one on the outstream as well. So you can see, hey, is there anything anomalous that I should be aware of? Is it being lost? Is compressed air being sunk? Is this a compressed air sort of heat sink? So essentially the outcome in base terms is you're revealing areas with energy saving potential to get you compliant and to get those cost savings right off, to start making cost savings as soon as possible. You might recognize this. This is the PBT. It's a compact pressure transmitter, and you can use that in conjunction to ensure that there is the pressure of the air delivered to those pods, the CNC pods, are at the optimal pressure. Now we can see a lot of this as well, a lot of integration between the FTMg and sort of the sister devices for pressure and pneumatic air monitoring. We'll see that in case two as well. See a familiar face here as well. So pressure, I beg your pardon, case two is a conveyor line. You can see this kind of arm moving up and down with supply. So it's, imagine it's sort of hovering on bursts or bursts of compressed air. So more bursts you have here, the more liable that line in this machine is going to be subject to a lot more vibrations, a lot more looseness, just a lot more in terms of leakage as well. So again, that 7 days logging, it's a common theme because you want to identify peaks and troughs. You know, you might have the conveyor at one speed, and there's you can sort of see, oh, here's sort of the flow and pressure and energy consumption. But if it's on a faster routine or faster cycle, you might see more and more sort of losses, more spikes in consumption or troughs when it's actuating on and off. And you might see here a pack 50 just hovering in, might be a bit faded or a bit hazy on your screen. So the pack 50, it's a popular. It's also a popular pressure switch and used in sort of clean pneumatic air as well. And that comes into its own when you've got really small lines or compact spaces. You know, it's paired with the FTMG if you'd like. So those are two cases. I'm going to go on to placement. Now, placement is where are we putting this? Where is it going? Where best to think about? So I've just had a doodle here on the right hand side. Got a compressor, post compressor. You'd have a big one, maybe a DN50. Put that one here, and you've got your manifold lines distribution. If it comes back into common, so if you want to put one here, one downstream, and then you've got smaller lines feeding into the machine. So that will be DN50 maybe, DN15 here. It depends obviously on line sizes. So stagger them out, put them in sort of strategic locations. Now you see here, you get we're sort of sources for leak, and sort of we've got the compressed air circuit here, and we've got little bubbles drawing in. Now that's just general wear and tear deterioration. On the right hand side here that's just loose fittings. These fittings come loose over time at any juncture, and here as well, again, a feed to the machines as well, where there's a lot of vibration, there's a lot of tip tapping, there's just a lot of shocks, anything that can dislodge the line. So you've got it crafted, FTMG crafted, kind of so it can be applicable to these sort of scenarios. You know, at all junctures of your compressed air circuit. So yeah, and just to reiterate, you know, compressor downstream feeds into and it feeds out the machine to see what's going on with that machine, what's going on with the compressed air. So where is it being undetected? That's where it is. And things to consider is obviously your compressor duty and sort of the topology or sort of relative elevation of your compressed air line. But again, SICK and Underwoods can work with you to kind of help you plan that as well, if you'd like guidance. So we're going to look at sort of costings next. Potential savings. What are we looking at? Now, the table on the right hand side is per single leakage. Now, these are based at 1.5 pence per normalized meter cubed of air, and that was according to the Carbon Trust. So, hey, as you'd expect, the bigger the leak, the greater the leakage rate, the greater the cost. Now, this is looking at one leak. Potentially, there could be 10s, 20s, 50s, potentially 100 leaks or so along your compressed air circuit. So, already from the outset, we can discuss prices of the device, but you are making a return on investment on anything at a 0.5 or a 1 millimeter leak. If there's multiple, then you're already making a return on investment for that year. I'd just like to say that these are kind of guidance. It's not set in stone. These are dependent on site location, air utility costs, the heating costs for that air, you know, your compressor, electricity for to drive that compressed air circuit. So this is just guidance, and it's going to vary wherever you are. So, for example, with that real-time temperature feedback, you know, is that compressed air running too hot or too cold for your delivery? Is it in spec or out of spec? You know, you don't want to introduce more opportunities for condensation, that air cools. You don't want more of that kind of bother, more of anything like condensation in line. Just meet needs to obviously wetness. Without wetness, you get more sort of corrosive elements, sources of corrosion, more integrity issues for your compressed air line. So it's just something to kind of focus the mind on what we're expecting based on their sort of calculations. And these sort of SICK worked with Carbon Trust on this. So we're going to look at Next now is the data management. Now, in essence, the beauty of it is that it's versatile. We've got at the top end here, it's kind of like FTMg, but with a sort of a light solution here. You just compile the data yourself, and you've got your own solution. That could be an industrial edge app. It could be an IT/OT solution. And as we dig in through options 2 and 3, it gets more and more integrated with the SICK sort of fabric. You've got with the SICK's own patented energy monitoring system with a gateway and what they call the energy monitoring box, which essentially options 2 and 3 essentially center on the monitoring box. So the monitoring box incorporates a browser itself, the web browser, cloud-based data management, and the built-in monitoring apps. So the SICK have got their own monitoring apps, which is basically like a dashboard. You can see red is bad, or red, green, yellow. You've got that dashboard there. So if you want to create your own solution, you can. If you want to integrate with SICK, then you can work with SICK as well. They can certainly work with you, because ordinarily, if you wanted to make your own solution, then you've got to pull together your PLC programmers, your IT team, software manufacturers as well. If there's like a BMS service as well involved, you've got to pull them all together and try and get them working from singing from the same hymn sheet. But with SICK, essentially SICK can work with you as well, and obviously I can't delve too much into it, but right now, in terms of expertise, SICK will have the expertise on hand to kind of tailor-made your system and manage that app as well. The right alerts to learn your system as well, to help you make sense of that data for your system. So it is kind of bespoke as you get to options 2 and 3. We will delve into it later offline and with Nick and the fine SICK support crew, in technical support here and in Germany. But it's essentially, what are you guys looking for? Do you want flexibility across the board? Because you can get it. If you want to scale up, then you're free to scale up as well. So whatever you're looking for, we'll help craft the solution. And just want to alert you, when you're on the Ethernet version, this is what you're looking at, the trending. That's kind of a snapshot of the trend data as well. So yeah, if you want to craft alerts and the like, you can get that done. If we're looking at you're looking at data solution, you want to use it to switch out or do something kind of like stuff that you can handle, you can use that with option 1. So I'm going to look at concluding, wrapping this up. Now, why are we here? The FTMg just enables reliable data trending, and it's a bit of a buzzword, but transparency. You can see now where it's being lost, where it's been overconsumed. Are there opportunities to streamline my process? And we all know that it's a key process parameter, compressed air. There have been a lot of solutions on the market, but with SICK now we can visualize the data and get it done in a versatile way to make sense to you, your stakeholders, and get useful data out, rather than a stream of data on Excel files or charts that are kind of clunky to click in and out. And as we looked at the table attributed to the Carbon Trust, we're thinking compound losses are kind of scary when you think about it. There was a singular losses, but and then putting in the man-hour to try and patch them together, or look for the undetected leaks first and then patch them up. So it's just compounding the initial sort of loss. Now, what we're here for, just to wrap up, it's hovering there. Measuring pressure and temperature without the need for additional sensors, along with flow, your volume, and the energy consumption itself. It's all in one device, and conformity to the ISO standards as per the sort of the energy management schemes. And I know more and more customers are sort of asking us and looking at ways to bring them into compliance or keep them, so they don't run afoul of those rules. So just to wrap completely, what we're here for, what our take-home points. It's real-time data trending up to 7 days. So it's continually monitored over those 7 days. You can choose, days, hours, up until. Above all, it's transparent usage of compressed air to hammer down those costs, get onto them where you didn't know how much you were losing before, and getting to heightened process efficiency with visualization.